Swayam Prabha. Digital India. Educated India.
So now let's look into the little more detail of how the shaping operation is done. So why the shaping operation is required in the network. So this shaping operation is policing is primarily to curtail the or limit the rate of transmission from a particular user or the network coming into your network. Shaping is basically required for curtailing the or reducing the rate of transmission which are exiting your network. You do not want your traffic to exceed the agreed upon limit or maximum ceiling. Then how do we exactly do that? So it might also be the case that the bandwidth transmission, so the network 1 has got a higher capacity and it is connected to a large number of the users, but the network 2 has got a limited capacity and is not able to transmit or handle as many number of the packets as the network 1. So the mismatch between the network 1 and the network 2, the transmission rate mismatch between the 1 and the 2, and particularly the downstream routers are not able to handle the capacity. That time you want to reduce the, you do not want to burden the downstream router, that time the shaping is actually done. Again, the shaping actually uses the same leaky bucket or the token bucket algorithm. So thereby, by using this, doing the shaping, you want to control access to the bandwidth. How much of the bandwidth between this and this is used, how much of the bandwidth between this and this is used. So by doing that shaping operation, you are actually confirming to that, and at the same time you are ensuring that your own traffic going to the second network is not violating the agreed upon constraint. Otherwise, he is anyway doing the say policing operation, but you yourself, when you transmit to the other network, you do not want to violate that agreed upon rate. So that is why shaping, that is where the shaping is actually used. So you want to regulate your own traffic flow to the other network entering the other network. So that's about the policing and the shaping. Both of them we said that use the leaky bucket or the token bucket algorithms. So these are the two components of the traffic management operation, and the third component is the something called as the scheduling. So we did discuss earlier little bit in when we discussed about the traffic management, the first lecture. Here we look into the little more detail of what are the kind of the scheduling operations that are available at our disposal. And one of the primary thing why we want to do the scheduling is the capacity available at the any network is finite in nature. When I say the capacity here, I primarily mean the buffer capacity and also the bandwidth capacity. So here is a picture. Let's assume there is a router, and this router R1 is receiving traffic from the user U1, user 2 and so on, some user 10, and there is a capacity C that is available. C corresponds to the network bandwidth. The outgoing link connected to the router R1 has got a finite capacity C, and these users U1 to U10 are transmitting parallelly, and they are sharing the same capacity link available. So by if I want to give more priority to user 1's transmission, how do I do that? If I want to give least priority to user 10's transmission, how do I do that? So that differentiation is actually brought by using something called the scheduling operation. So one simple thing is one thing is the by sharing the outgoing link, you are utilizing the, you are bringing the optimization of the resource available resources. So same capacity link, when user U1 is not transmitting, user U2 is able to use. When both user 1 and 2 are not transmitting, the remaining 8 users are actually sharing that capacity. Assuming at any point of time only one user among the 10 is transmitting, he is getting the complete share to the A1. So in a nutshell, what we want to do is whatever the resources available, I don't want to keep that idle. I want to utilize it the fullest capacity. At the same time, all of them the available users, you want to serve the more number of the users, the best way to do, and that too even more number of the users with a differentiated survey quality of service. So, one user traffic is given the priority over the other one. So, that is what is implemented using the packet scheduling. So, as I said, the goal here is to maximize the utilization of the available. At the same time, you want to give a fair share of utilization to all the transmissions or all the users. I don't want to maximize the transmission of certain user traffic at the expense of the other users without giving any share to the other user. I don't want to hog the network. One user traffic is only taking the complete bandwidth. That situation I don't want. So, any scheduler that you design need to ensure that these two conditions. One is maximizing the utilization of the available bandwidth or the resources, and at the same time you want to be fair to the all the users or all the applications or all the network from which you are actually receiving the traffic. There are bunch of algorithms or mechanisms that can use. This scheduling operation is in turn governed by the how much of the bandwidth you want to give. So, they work in tandem. Policing, shaping and the scheduling operations work in tandem, and so something which is not confirming, if you want to apply the traffic shaping or the policing action, there you first decide and then you put it inside the buffer, and from that buffer you actually alter the scheduling operation and then you bring the notion of the priority. So, this operation which requires you to alter the way in alter the order in which the packets are exiting your router requires you to do some kind of the computation, and you want to bring the fairness among the users and the applications. So, there are bunch of scheduling algorithms available. These scheduling algorithms are broadly classified into different categories. One is called as the class based scheduling algorithms and flow based scheduling algorithms. So, the difference is the following. In the class based scheduling, you assign a class or the label to the end user traffic. So, let us go back to the previous discussion, previous diagram, router R1, and you got user U1, U2, so on U10, and there is an exit link or outgoing link, and I mark the user U1 as the gold class customer, user U2 as silver class customer, user U10 as the something called as the bronze customer, and I am going to assign a priority. Gold customers always have the highest priority, silver customers have got the less priority, bronze customers have the least priority, something like that. So, I map the users into some available classes, and then each class is given a priority, and accordingly you do the scheduling operation. That is how this scheduler works. The other way of doing the scheduling is something on the flow based scheduling. So, user wants traffic is marked as one flow, user used traffic is marked as the second flow, and user U10's traffic is marked with some other flow, and then you write a rule by using a combination of the source, whose user's traffic it is, which application it is. So, from the same user, if multiple applications might have different priority assigned to that, you can bring fine grained notion of the priority when you do the flow based scheduling. So, you can map it to the earlier discussion that we had with respect to the packet classification. Packet classification is actually done with a set of rules, and using those rules you are actually doing the differentiation, and this exactly same thing is happening here. The scheduling operation. Scheduling is one way to implement what the classifier is actually telling you. So, this is the flow, you want to take this action, then how do I do that? I tell my scheduler to do work accordingly. I want to transmit this faster, quicker, I want to delay this, I want to drop this. Accordingly, your scheduler can work what to drop, what to transmit it quickly, and the rules and the rules dictate what to transmit or what to be given priority. And the second class of the algorithms or the mechanisms or second classification is something with the preemptive and the non-preemptive scheduling mechanism. If you can recollect our earlier discussion, a router has got a queue and the packets are arriving and they are put inside this queue. Let us say P1, P2, so on, P6 are now inside this queue, and let us assume for the sake of discussion that this queue capacity can accommodate only 6 packets and 6 packets are already full, and a new packet arrives, P7 arrives at the input queue on the line card, and you do not have the capacity to place that P7. Now, it depends on the mechanism how your scheduler is working. If you have assigned the notion of the priority, let us say P1, P2, P3, P6 are having the priority 1, 1, 1, 2, 2, 2, something like this, and P7 has got highest priority, let us say 3. Now, a higher priority queue has arrived at the input port, and you have already marked in what order the packets already queued up or the buffered inside your router are going to exit the router. The order of the scheduling is decided. Maybe I am going to transmit this packet in this order 1, 2, 3, 4, 5 and 6. This order is decided, and if your router you are giving the priority to P7, now what you do? So, all these packets have not exited the router, they are queued up, but they are, you decided in what order you are going to send them. So, if your router, if your scheduler is preemptive, what it means is I am going to halt the already scheduled set of the packets if arrival of a new packet with the highest priority will take precedence. I am going to halt the transmission, scheduled packets transmission, and transmit the highest priority packet now. This action is called as a preemptive scheduling, and in the non-preemptive scheduling, although this might be highest priority queue, but already I have made up my mind in what order I want to transmit it. I am not going to disturb that, but if I have the available capacity, I will put it inside the queue. Now, using starting from that point onwards, I am going to decide in what order the subsequent packets are going to be transmitted. That is called as a non-preemptive. Both versions you can make use of. So, the next classification is something called a conservative versus non-conservative. In the conservative technology, you decide to transmit it whenever there is a packet available. If there is no packets available, then you may not be able to schedule the transmission. In the non-conservative mechanism, you can even when you can decide when the packets are available, then also you may not be able to transmit it. That is the difference. So, if there is a capacity, you transmit it at certain point of time, you might also decide to keep the link idle. So, that is the 3 different categorization of the scheduling algorithms or the mechanism that you can use inside your router. So, now after having understood the class of the schedulers available, now the question I want to ask is how do I implement these schedulers, what type of the schedulers are actually available. So, there are many type of the schedulers available for packet scheduling. So, the simplest form of the scheduler is something called as the FIFO scheduler. So, this we discussed earlier. You have got a queue and the router has got a queue, and the packets are arriving at the input port and the packets are exiting at the output port, and in between you have got this queue, and what you do is you pick up the packets from the input port and put them inside this queue. So, let us say P1 is the first packet arriving, P2 is the next one, P3 is the next one, P4 is the next one, P5 and P6. In this order, the packets have arrived at the input queue, and the scheduler, what it can do is it can schedule the first packet. This is the first one to exit, this is the next one to exit, this is the next one to exit, this is the next one, and so forth. In the order in which the packets have arrived, in the same order the packets are exiting the network. That is called as the PIPO scheduler. This is the default scheduler that is available inside any router. So, there is nothing fancy happening here, just you put them. If there is a capacity inside your buffer, you put them, or in the queue you put them inside the queue, otherwise you discard and you make them exit in the order in which they have arrived. There is no alteration that is happening here. This is the simplest form of the scheduler that is available. So, if you can recollect our earlier discussion, so many of them routers may have multiple queues. Maybe I might have 3 queues. Let me call those queues as Q1, Q2, Q3. This is queue number 2, this is queue number 3, and there is an output line. The scheduler which is sitting here is picking packets from this queue, it is also picking packet from this queue, and this is picking packets from this queue, and the packets, incoming packets, are put inside this Q1, Q2, Q3. And what I can do is I can tell my scheduler yes to pick up packets, one packet from the Q1, one packet from the Q2, and one packet from the Q3, and you go in order, you recycle. So, every time you pick up one packet from the Q1, you pick up next, you pick up one packet from Q2, and so forth. So, it is not necessary that you have only 3 queues, but multiple of them might be available, n queues. So, you sequentially go one after the other and then you recycle. So, this is called as the round robin scheduler. In a way, round robin scheduler is again not doing anything fancy. It just your packets are segregated and put into different queues, and then it is picking equal amount of the packets from the each of the queues. So, now only differentiation that you can bring here is if you are able to put the packets, let us say a particular user's packet or particular application packets are put inside the queue number 1. If the rate of arrival of that packets from that application or the user is different, then the number of the packets that are available in the Q1, Q2, Q3 might vary. So, different applications are transmitting at a different rate, and assuming I put for each application I have a queue, then the number of the packet inside this queue might vary. So, at any point of time, if certain queues are not full, they do not have the packet to transmit. Let us say for the sake of discussion, Q2 does not have any packet to transmit inside its queue. Now, the packets from the Q1 and Q3 are picked up. In next subsequently, if some packets arrive at Q2, now I go in that order Q1, Q2, Q3, but any number of the queues which are empty, those are packets are not picked up from that. Only the whenever packets are available in some queues, you pick up from there and schedule it for the transmission. So, that is how the round robin scheduler is working. So, now the next variation that you can bring is, so here round robin scheduler is actually giving equal opportunity to all the queues. So, you are not really able to differentiate when the transmission rate of all the applications are equally good, or it is just sufficient to put the queues full, then the round robin scheduler is not exactly doing anything fancy. It is as good as the first in first out scheduler with slight difference. So, how do I bring the differentiation? So, that is where the priority scheduler comes. So, what it does is it assigns a priority to each of these queues P1, P2 and P3. I might tell my scheduler that P1 has got the highest priority, next highest priority is P2's, and the next one is P3. So, scheduler would pick up the packets from the P1 highest priority queue always. If Q1 is empty, then you go and pick up the packets from the P2, and if P1 and P2 both are empty, then you pick up the packets from Q3. Q1 and Q2 are empty, then you pick up the packets from Q3. So, that is called the scheduler. So, you might assign different priority to different queues, and then you pick up, you tell your scheduler, you always look for the higher priority queue packets from the higher priority queue and then schedule them for transmission. So, what we understood earlier is, if you use this mechanism, then if there is a constant arrival of the packets of the highest priority queue, then others will not get a chance to transmit, they would be independently starving there. So, that is not desirable. So, remember, the objective of the scheduler is to be fair to others. So, if I do this operation, if I tell my scheduler to do this, always transmit the highest priority packet, then the packets might, you will not be fair, and packet might be independently waiting inside the queue. So, how do I exactly avoid that? So, that is where the weighted round robin come into picture, where you assign a weight to each of these queues. W1 is the weight assigned to, now I do not have the priority, but I have the weight assigned to the queues. W1 is the weight assigned to Q1, W2 is the weight assigned to Q2, and W3 is the weight assigned to Q3. So, for the sake of assumption, let us say the numbers are in fractions. W1 has got 0.2 and W2 has got 0.6 and W3 has got 0.2 as a weight. And what it means is, if you have total Q1, Q2, Q3 has got 10 packets to transmit, every 2 packets exiting are selected from the Q1, there will be 6 packets selected from the Q2 and another 2 packets are selected from the Q3. Together you would be able to transmit 10 of them. So, like that I can define a notion of the weights, and then I accordingly, whatever the weight is there, accordingly I pick up the packets from different queues and then transmit it. That is the weighted round robin. So, I go in round robin fashion, but at the same time I alter the number of the packets picked up from each of the queue, which is dictated by the weight assigned to that queue, and then you transmit it. Now, you can think of a simple utilization of this one is, maybe the highest priority one, which is a 0.6, is serving the user which has got the highest priority, or the application which has got the highest priority, and the remaining the Q1 and Q3 have got the other priority. The next 2 applications have got the same priority and they are served from this Q1 and Q3. That is how you utilize the scheduler to bring the differentiated service.